First, we start off stating the null, and that it is possible that magnetic fields can reduce pain. We just do mu1 equals mu2. The alternate is that it's not possible that magnetic fields can reduce pain, so mu1 is not equal to mu2. First, we calculate the D, the difference of squares. We go to the Excel spreadsheet. I calculated, plugged it all in. We get a M. The mean of D is 5.62. Then we have to do the sum of squares of the D, as I have it here, and that is our answer, 276.83. Then we get the degrees of freedom, pretty easy, 29 minus 1 equals 28. Then we have to get the variance of the D score. That's the formula. We're just plugging in SD right here, the degrees of freedom of D, 28, and we get the answer of 9.89. Then we have to find the standard error of the mean scores. The formula, again here, it's just plugging in numbers. The SD, what we got here, 9.89, and then the number of D, which is 29. We just reduce it, get a square root of 0.34, then you reduce it out to 0.58. I just put these up here so I won't have to flip the page, but then we have to calculate T. So this is the formula for T. It's just plugging in again. Right here for mu D, we just add a 0 so we can get a difference. And but it's just plugging it in again. So that's 5.62 over the SMD, which is 0.58, and we get the answer 9.69. Then we have to calculate Cohen's D, and that's the formula we're plugging in. So 5MD in the previous page, the MD is 5.62. SD2 in the previous page was 9.89. Reduce it down. That's our answer, 1.79. Then we have to go to the T table. The degrees of freedom, you have to find the degrees of freedom, which is 28. You come over here, get 28. Then the alpha is understood that it's 0.05, and our answer becomes 2.048. The T-calc is -1, and the T-crit is greater than the T-calc, with a P is greater of 0.05. And the APA style is possible that magnetic fields reduce pain levels, with level 1 being this, level 2 this, and then the rest with the Cohen's D.